Welcome to section 2.4. In this section, we're going to expand our Venn diagrams, and now you're going to have 3 circles with 3 sets. Not only will we expand the diagram, but you're also going to need to verify whether sets are equal or not. Okay, so when you have 3 circles with 3 sets, you're going to have 8 different regions. So, for example, if you look at your blue circle A, Section 1 is just items that only have quality A and nothing else. But if you look at Section 2, where A and B overlap, this would be something that has qualities of both A and B. Section 3 is B and B only. Section 4 is qualities of A and C. Section 5 in the middle will have all 3 qualities, A, B, and C. Section 6 will have qualities of B and C. Section 7 will have qualities of C and C only. And if they land in Section 8, that means it did not fit into any category of A, B, or C. Okay, so I have an example here for you, and I just used numbers. I didn't use any type of verbal description, but you'll have verbal descriptions on your homework, so this will give you a general idea of what's going on. So let's construct a 3-circle diagram. Our universal set is the numbers 1 through 15, and I have sets A, B, and C described above. So first thing we need to do is we need to draw ourselves a rectangle to represent our universal set. We are going to need a circle for group A. We are going to need a circle for group B. And we need a circle for group C. Okay, so what I like to do is I like to find the stuff that they all have in common at the beginning. So one thing I notice is if you look at set C, B, and A, notice that they all have the number 4 in them. So you can take that number 4 and you can put that right in the triple overlapping area because they all share that trait. Also, they all have the number 9. So again, you can take the number 9 and put those right in the middle. Okay? I don't see anything else that A, B, and C all have in common. Okay, so let's look at some other numbers. Okay? So let's look at the number in the set A. The number 1 is in set A. Notice that it is also in set C. So I need to put that where A and C overlap. The number 8 is in set A. Notice that it is also in set C. So I need to put that where A and C overlap. Number 10 is in set A and is also in set B. So I need to put the number 10 where A and B overlap. Number 12 is in set A, but it is not in set B or in set C, so that's going to go in the little area all by itself. But notice I have set A complete, and it includes the 1, 4, 8, 9, 10, and 12. And all of that red circle makes set A. Okay, so let's look at set B. Okay, set B has the number 2 in it. That does not occur in C or A, so that has to go by itself. Set B has the number 5 in it. That does not occur in C or C or A, so that has to go by itself. And set B has the number 13 in it. That does not occur in C or A, so that has to go by itself. So notice that this little section right here is empty because they don't have anything in common right there. And that's okay. That happens. Okay. Let's look at group C. Group C has the number 3 in it, And that does not occur in A or B. So that will have to go by itself. And group C has the number 11 in it. And that does not occur in A or B. So that has to go by itself. Now, any number that did not get used, I actually did use 12. I just forgot to write it down. Any number that did not get used, so the number 6, the number 7, the number 14, and the number 15, those need to be represented, but they don't get to go in any of the circles. Those have to go in the rectangle because they are not part of any of the sets A, B, or C. So you'll run into problems that do a similar thing, but instead of using numbers, they'll use characteristics or traits. But you set it up the same way. Always try to find what they have in common first if you can. Another task they'll ask you to do on your homework is they'll ask you to verify whether two sets are equal or not. One way that you can make that verification is by using a Venn diagram. When you do a Venn diagram for both statements, if the Venn diagram you get is identical in each case, then you know that you have equal sets. Okay? So, for example, one of my questions asks me if A union B naught is equivalent to A naught intersection B naught. Okay, so what we would do is we would make ourselves a Venn diagram for each of those situations. Okay, so I'm going to do A union B naught first. Okay, so start it the same way. Start with your rectangle. Start with your A circle. Start with your B circle. Okay, the first thing they want you to do is you got to do your order of operations. So you got to do what's in the parentheses first. You have to find A union B. Now remember, A union B means the same thing as A or B. So that means that you would include anything that lands in set A, and you would include anything that lands in set B. That middle part gets shaded twice because it's in both A and B, but that's okay. So if I was just making a diagram for A union B, that could be represented in the green. That's not what they want. They want the diagram for A union B naught. So that means they want everything that is not in A union B. So that is actually going to be the red part, or the outside of the circles. Okay? So I'm just going to erase this little green area because that is not the area we want. We want the red area. So our red area would be our solution here. Okay, now let's see when we go and we do the other statement. So this statement says you want A naught and B naught. Okay, well let's look at that. Let's draw a rectangle. Let's draw circle A. Let's draw circle B. Okay, so if we're talking about A naught is anything that is not in the A circle. So that would be everything outside of the A circle, and I'm going to put that here in green. So this green is representative of A naught. Now let's talk about B naught. B naught is everything that is not in the B circle. So I'm going to put the B naught area in red. So anything outside of the B circle would be considered B naught. Okay, so our B naught is represented in red. Now the question is, where do these two items intersect? So where do you notice that you have both green and red? And if I'm looking, it looks like it's all on the outside. I've got a little bit of red only in the A circle, so that's not included because I need both green and red. And I've got a little bit of green only in the B circle, and again, that's not included because we need both. And do you see how the intersection on the right looks identical to the graph that we created on the left? That would symbolize that these are equal sets. So if you want, instead of doing A union B naught, you could do A naught intersect B naught. This is actually a law. It's De Morgan's law. There's two versions of De Morgan's law. We've already shown the first one. A union B naught is equivalent to A naught intersection B naught. There is another version that A intersection B naught is equal to A union B naught. A naught union B naught. All right, good luck on your homework and let me know if you need help.